Okay, let's see some examples now for constructing a mean confidence interval. I have here a sample data set, which represents the number of senior management employees in a randomly selected tech company who identify as Black or Latinx. So they are either in either one of these racial identity categories, and each value here represents the raw number, the actual number of those senior management who identify as either one of those. And we will be estimating, so our task here is to find a 95% confidence interval for mu, which is the population mean of senior management who are Black or Latinx in a tech company. So we have to make sure before we begin that we have everything that we need and that we can use the construction that we've laid out. So first of all, we have a very small sample set. So we have, first of all, n is 10, is very small. This is not usually what we want when we're constructing a confidence interval. We usually want something greater than 30. However, if we can reasonably assume that the sample data come from a normal distribution, then it should be no problem. So we'll reasonably assume the underlying distribution is normal. Most likely than not, this is we're talking about something similar to Poisson, maybe, or even possibly binomial with a not very large number of trials. But because in both cases we're talking about a discrete distribution that can be approximated with a normal distribution under ideal conditions, then we'll go with that. And in this case, we are not given directly our point estimate, nor are we given any information about the population distribution other than it's normal, and we're not given sigma, which is the population standard deviation. So we'll have to estimate. So we take sample statistics, x bar the sample mean, which if you want to calculate this yourself, you can either use a calculator or calculate it directly. So this is the sample mean of this distribution. It's the sum of all the data values divided by the sample size, and we find that that's 2.3. And the sample standard deviation, which is a slightly more complicated calculation, but you can use a calculator again, we find that that is 1.77 roughly. And so now that we have this, we know we'll use a t-interval construction. So the margin of error is given by t of alpha sub alpha over 2 times s divided by the square root of n, where specifically, right, we have a confidence level 1 minus alpha equals 0.95, which means alpha is 0.05, which means alpha over 2 is 0.0025. So 2.5% in the upper tail is what we want for the... This has the t-distribution with degrees of freedom n minus 1. We found that n is 10, so our degrees of freedom is 9. We can either use a table, or we can use inv t, on a TI-84. So, to wit, if we are looking for this critical value times the standard deviation divided by the square root of n, we find roughly that this is going to be 2.262 times 1.77 divided by the square root of 10. At this point, we're approximating, so we don't have to keep anything exact. And this is roughly 1.266. So our confidence interval is explicitly given as our lower bound is x bar minus e. So our estimate, which was 2.3 minus 1.266. And that's exactly 1.034. And our upper bound is x bar plus e. So that's 2.3 plus 1.266. And that's 3.566. So, in conclusion, our 95% confidence interval is 1.034, 3.566. And so we're saying with 95% confidence, we would say that our population mean lies between 1.034 and 3.566. And remember that we can obtain E with much less computational work if we use t-interval on a TI-84. But that doesn't save us from this last step of finding the lower bound and the upper bound for our confidence interval, which says that roughly we can expect between 1 and 3.5 people to have an identity that is Black or Latinx. On the other hand, we may be interested in if we are given some additional information about the standard deviation. So, suppose that we're given that for the number of times a day that a girl is redirected, gender role enforcing activities we know from research that the standard deviation is 2.5 times, and in a sample with sample size 85, that the mean is 11. So our task now, find a 99% confidence interval for the population mean. In this case, because we're given such a large sample size and we're given that the exact value of the population standard deviation, then we can use the z-interval approach, right? So z-interval approach, which means our margin of error is the corresponding z-score with alpha over 2 in the tail times the population standard deviation divided by the square root of n. remember that this comes from the standard normal distribution. We can use invnorm or a table quite easily. And we're also given, if this is 1 minus alpha, that alpha is equal to 0.01, and alpha over 2 is 0.005. So to wit, the critical value with 0.005 in the tail times sigma over the square root of n. Well, take a moment, if you'd like, to find those values. And they're given to us in the statement, or we have to use some tech to find them. But 2.58 times the standard deviation is 2.5 divided by the square root of 85. And that is 0.962. And if you're following along in the book, that is a typo, I believe. It says 45, but it should be 85. But then this means then our confidence interval would be, we estimate mu is 11 with a margin of error of, give or take, plus or minus 0.962, which of course translates to, if we subtract or add, so find the lower bound and the upper bound, we have 10.038 on the lower end and 11.962. And the reason why this is such a tight confidence interval is not only because of the sample size, but how low the standard deviation is. And so this is quite precise.